Exercise 11, SolidWorks 2016. In this exercise, we're going to take a look at the sheet metal functionality inside SolidWorks. We're going to take a look also at the difference between some of the older tools, the original tools as I call them, that came out in the 90s that are still available. And that's what I'm going to start off with, because with those you could do almost 95% of the sheet metal functions that are necessary with that. Then came the other tools that came out around 99, 2000 and thereafter, and those are phenomenal as well, and those allow you to do all the complex things as well as mix just things a lot easier inside sheet metal. So we're going to begin with this one. This is, again, the first one is going to be using some of the older tools, and let's first download the file. So go to the vertani1.com part files, find exercise 11 parts, click on it, and up here go ahead and download. I'm using Google Chrome for this, and I'm going to just click here and show in folder, and I have it over here to the right, and I'm just going to go ahead and find that there's that folder, double click on it, and I'm just going to right click on the E11 and cut it out and paste it on the top level directory here. And I could double click and I can maximize the views. Alright, what we're going to do is I'm just going to double click on exercise 11 inside that folder, and here you can see it's a little different from the manual, but essentially the same file, just a little bit more detailed. There's already an enclosure over it. That's just so you could interrogate the original model if you want to look at how it was done. I'm going to go ahead and hide that, so I'm just going to click on it, click on the eyeball, and it's hidden. Now we're going to build that same enclosure around this. So let's begin. First of all, bring up your sheet metal tools by right-clicking on any of the tabs that are here. And before you do that, actually, one thing you'll notice, sheet metal is not there. That's because we're currently editing an assembly, as you see down in the lower right corner. So we first need to insert a new part, then it will enable us to find that. So let's go to New Part, and go ahead and just drop it in on the front plane of the assembly over here in the feature tree. Where that lies is approximately just on the surface of the ends of these bosses. So that's perfect for us because that's as far as we want it to extend for the enclosure. So with that being said, go ahead and select now what, again, this is top-down modeling with sheet metal. So some of this, if you're just going to this video without knowing what top-down modeling is, you can watch exercise 10 and exercise 11, which goes into more detail. I just don't want to be too redundant with that. But go ahead and let's select this face, and that surface is our front plane where that origin is. So we could select this face, and we could hit Convert Entities, and it will automatically project the edges onto the surface of the new part that we dropped in, which is the front plane, I should say. Okay, let's go to Features and Extruded Boss Base. Go ahead and extrude it up to this vertex. You can just simply click on that and hit the green check mark or right mouse button, click. And now you can see it's overlapping as a solid volume surrounding this. What we're going to do, we're starting off with a solid, we're going to shell it and then convert it to a sheet metal part. That's one method of doing these things inside SolidWorks. Okay, now that we actually have it there, I'm going to right click on it. I click on the part, and we want to open it up. This is going to isolate that part by itself and keep it in this view that we currently have. And let's go to the shell command, and we're going to set it to 0.06 for the thickness of the sheet metal. Go ahead and select these three faces that are exposed right now. And then to select through this back face, to get this back face on the left, rather than rotate, try this. It's just a good little tip I'm about to show you here. You all know how to rotate already. But right click, and there's an option, Select Other. And as long as you right click, see where my little pointer was, it will show you the back face and allows you to select it from the list. Go ahead and select that. Now all those faces are selected. We could go ahead and one last thing. Select Shell Outward. This will make our sheet metal on the outside of this volume, so that will fit over the cover, or fit over the gears and that casting that we had copied the edges from. So that's why we're doing shell outward. Hit the green check mark, and we're left with this. Now it's still not a sheet metal part, although it's thin, but let's go ahead and convert it to sheet metal. Up at the top here, you'll find the sheet metal tools. In this case, I didn't activate them yet, so I'm going to right click on any of the tabs, and there you'll find sheet metal. Once you select it, click on the tab, and you'll find there's lots of different sheet metal tools in here. What we're going to go with is the Insert Bends tool. This is the very first tool SolidWorks came out with back in, I want to say 1997. Yes, I've been teaching it that long. And like I said, it can do many of the things that you would want it to do, just not all of them. That's what all the other tools are for. Okay, now over here, we have to select a fixed face. Select this bottom surface right here for it to be fixed. That way, it's going to unfold around it. Now, we'll specify the internal bend radius. We could set it, we'll actually keep it at 0.029, the default. Now, the bend allowance, if you hit that little arrow there, you'll see you could go with K-factor, bend table, bend allowance, bend deduction, bend calculation. There's lots of options in there. K-factor, at least in the Midwest, seems to be the most commonly used one nowadays. When I first started off going out to customers, I saw a lot of people had these old 3-ring binders that looked like little encyclopedias of lists, tables of all copied tables of bend allowances for different types of materials. And you used to go ahead and just plug in the explicit value through the, actually you would just go to bend allowance. But anyway, now you could go with K-factor, and SolidWorks defaults at 0.5 for the K-factor. If you're curious what the K-factor is, you could click on the little help button here, and the SolidWorks help comes up, which is just phenomenal. And let's shrink it down, and here you can see K-factor and related concepts. And this gives you the equation for the K-factor, and it shows you an image of what it's talking about. Again, I'm not going to go into all the descriptions on that, but needless to say, a very common K-factor that I've seen is about 0.32, 0.34. It's kind of a sweet spot almost, it seems, out there. 0.5 I've seen on a lot of machines when they fabricate it, sheet metal fabricators. Comes out, you know, anywhere between 15 to 30 thousandths oversized. So just be aware, you might have to adjust that for your material. Okay, so we're 0.34, and then the relief. You'll notice that there's 3 options for rectangular, tear, or obround. Again, we could go ahead and look that up, and you could see actual images of what these are. So let's take a look here. And they usually have a pretty good image of what the obround looks like. And here I'm not seeing it. Somewhere in here there is actually, let's do a rectangular. Okay, anyhow, I'm not seeing it offhand, but essentially what it does is obround is typically used for people who die cut, if you're die cutting little or stamps, because if the die has a sharp little edge on it, when it makes a little relief cut, it's going to wear out after a while, versus an obround is a nice radius around there. Rectangular is great for laser, plasma, basically those types of techniques, water jet. And then tear, we used to use that at the company I worked at quite a bit for medical as well as food service. And essentially, it instead of leaving a gap in between where the bends take place, it actually just tears it. It's a very tight area. Therefore, organic materials can't get trapped in the corners. Like, for example, if you're using this on a countertop, for stainless steel countertop, and organic materials can't get trapped as readily inside those corners. And thus, we used to use tear quite a bit. Anyhow, I'm going to go with rectangular, keep it at 0.5. That makes it the length width approximately 50% of what the thickness is. So in the rip parameters, finally, click on here. And we have to rip this edge and this edge out. Now, you see the 2 arrows pointing in those directions. That's going to completely notch out the corner. If you click on it again you can match this, and essentially it's going to follow this face. So imagine taking a blade here and cutting through this flange here. That's what it's going to do. Now if you click them again, now it's going to follow the blade. If you're taking like a hacksaw blade and you cut this through, it would follow this surface. It's kind of like its jig. So I'm just going to notch it out completely. In this case, you hit change direction over here too. That works. And it's going to notch it out 10,000ths. I'm going to go ahead and hit the green check mark. Now you'll see this is not a warning. It's just letting you know auto relief cuts were made. Hit OK. The auto relief cut it had to make was in the corner here to allow it to bend freely. The reason the relief cuts are there, if you're not familiar with sheet metal, is essentially if you've ever wrapped a Christmas gift or a gift to someone for a holiday or whatever it might be. When you wrap those corners, you'll see that they bend and they kind of get these like little ripples in the corners. Same thing could happen with sheet metal, and so you put a little cut in the corner and that prevents that from happening to some degree. Okay, and you'll also see if I rotate this around the backside, it completely notched that out. And remember, that was completely connected at one point in time. Now we could go ahead and just select the flatten tool to preview what it looks like. And there we could see the flattened state. And here you can see the rectangular relief cut. Let's go ahead and click on flatten again and it will fold it back up. Now if you wanted to do some additional things in here, like maybe make a cutout in the flattened state, there's a lot of different options for that too. We're not going to go into that just yet. I have several other sheet metal exercises you can watch for that. Okay, let's bring this back into the assembly. I'm going to hold Control and I'm going to hit the Tab key one time and it will bring it back. And yes, I do want to update it. And you can see now it's enclosing our gears. Okay, but the thing is, what we'd like to do next is there were some screw holes up here that we want to go ahead and match up on here, so machine screws could go in and fasten it down. So we could go ahead and click on this part, and it still actually is in edit mode, but click on the surface and start a sketch. Now be sure to hit escape here a couple times, because what happens if you still have that face selected, what we're about to do will copy the edges of that face and cut the whole section out accidentally. You probably don't want that. So make sure you hit escape before you do this next step. Now let's go click on the space bar and click on the top of the cube, or go to the top view orientation, and let's go to wireframe. With wireframe, we can actually see the screw holes here and here. Go ahead and control select those edges and now just hit convert entities. If you want to offset or have it a little bit larger, go to offset entities. But I'm going to click on convert entities, and now if we go back to shaded mode, you'll see that we have those. We copied over the holes. Now just to show you, I'll do it later. Basically, those holes were pre-existing. We just took the circles off the edges. Now we could go to features and extruded cut. Now with sheet metal, there's a link to thickness option. Go ahead and select that. That way, sometimes sheet metal folds on itself, but you want a hole to only go through one of the layers. This way, that will work. So instead of selecting through all, select this as an option if you're just trying to go through one layer of the sheet metal. Normal cut, if there's a cut at an angle, or it goes in at an angle in its 3D state. In the flattened state, you can't necessarily cut that at an angle. It's usually cut flat. This compensates for that. Go ahead and hit the green check mark to apply. And now we have the holes, and you can see the holes in there for the fasteners. All right, now to look at some of the more modern tools that actually have been out for quite a while with SolidWorks, but they weren't the original ones. This next one, we want to put a flange on, and so I'm going to go over here to the sheet metal tab, and I'm going to go to edge flange. Go ahead and select this edge. Depending upon the edge you select, the way this direction it's going to bend typically. So click on this edge and then just drag this over and select a corner to have it stop at that. Now you could go over here to edit the flange profile in the feature tree. Move this over, don't just hit next, just move it over, let it sit by itself. Now you could grab the sketch geometry and manipulate it and move it to your liking. And then you could also dimension to it. You could use the dimension tool. You could also steal, like let's say I want to take that edge, because I want this flange fastened to it, but yet I want to lighten it. I don't want it to encompass the whole area, and maybe on this side it doesn't need to. Hit the convert entities, and again over here, let's just drag that out a little bit further, and hit finish. Okay, now here's a little error. I mean, here you can see the actual rectangular relief cuts that I put in, and it's not SolidWorks error, it's my error. I'm failed to do something. In this case, you can see it's intersecting the geometry. Let's hit the little arrow to the left here, and you could easily edit this. Go to the edge flange that we just added, and go to Edit Feature. That takes us back, and one of the options was to actually place this on top. So right here you have flange position. Click on Material Outside. You'll see now it's on the outside. Hit the green check mark. Okay, you could do that again on this side. I'm not going to do that one. Now some of the other options in here, let's say we want to put in those louvers. And if we go to the design library, click on the design library, find forming tools, and you'll find embosses, ribs, extruded flanges, lances, and louvers. This is just a small library to choose from. SolidWorks on 3D Content Central has tons of different options. Rather than model them up, try looking there, you'll find a lot of options. You could also modify these. These are nothing more than parts. Look at that, louver.sldprt. And if you look at it, you can actually interrogate the model, transform it in any way you want, and save it off as a different size. All you do is you just drag this onto the surface. The tab key on the keyboard, before you release it, hit tab and it will pop it in or out. Don't worry about the rotation angle just yet, because over here you have the ability to adjust that. So if I typed in 90 and hit enter, you'll see it will rotate it. And then you have position, and you could use dimensions to locate where you want this. So you could select that point, and let's say you wanted it off of this edge, and we want it to be 1.5. Now we'll go with actually 1.75. Okay, now that that's there, hit the green check, and what you'll see is it actually generated a louver. And you could pattern these. You could just select it, go to the features and linear pattern, select an edge for the direction. Oh, clear this out actually. Select this edge, and then select the actual feature that you want to pattern. And then over here we just put in the spacing, and we go ahead and we put in how many instances, and you could flip it. Okay, and so at this point, if you wanted to make a drawing of this, what you can do is you could open up that part again by itself. And here, let's just take a look at the flat pattern. So you have to go to the sheet metal and click on flatten, and there's our flat pattern. And everything is in its position relative to where it belongs in the 3D state. Now to make the drawing, we just go to File, Make Drawing from Part. We got to save it. Oops. Oh, I have to save the whole thing. Right? Let's go back here. And let me get out of edit component here. All right, now we should be able to file, make drawing from part. Oops. All right, I'm going to go ahead and save this as a different. And we'll just call E11. All right, and now we could go ahead and go to File, Make Drawing from Part. We'll just take the standard format, and you'll see there's our flat pattern. And we could also drop in some of the other views. Could bring in an isometric and any other view we'd like to have. Now this, in this case, you might actually want to make another drawing that's to scale. So down here below on sheet, you could go right click on sheet and add sheet. And we're going to go ahead and edit the sheet format. Well, I'm sorry, we don't want to edit the sheet format. We're going to go to, actually, yeah, we'll go to properties. And I'm going to select a custom. Actually, let's go with an E size and then click on custom and hit OK. Let's try that again. No, properties. And there we go. We'll just drop it on here. And now you could go over to the right, drag in a new flat pattern, and you could specify the scale. So in this case, we'll use a custom scale. Let's go 1:1. So a full scale. Oops. There we go. And so we have something in a much larger scale, which we can now export that as a DXF or DWG. Just go to File, you do Save As, and you'll find DXF, and you can export that to a water jet or plasma or laser cutter. Okay, the next one we're going to do, I'm going to show you using the new tools to generate this next one. And this is going to be a bracket that you would find maybe in an automobile. Okay, our goal here, there's lab 10, on lab 11B is to create this sheet metal flange. So with that being said, we'll go ahead and start that. On the front plane, start a sketch, use the center rectangle tool, draw out your rectangle, go ahead and make it 5 by 2. And actually, let me just double check that. 1.25, my mistake. And then we could take the circle tool at the center, draw out our circle, and that needs to be 2.5 inches. And now we'll just trim everything out. So we could trim through there, through here. Stay away from those center lines. Don't trim those because those are needed to hold it together. Okay, and so now we have our flange. Just go to Features, Extrude Boss. Not Extrude, sorry. Meant to go to the Sheet Metal tab and Base Flange. And now you'll see you could drag this out. And if it's symmetric, keep it that way. Go by mid-plane and specify how thick you want that to go. 1.5. Hit the green check. Now let's say we want to round these off, these edges, so they don't cut anything. There's a neat little tool here known as the hem. You could go ahead and select the bottom edge to have it hem underneath, and you have close or teardrop. Notice what it's doing. You could do the same on this edge here and hit apply. Okay, select this face and start a sketch. Draw a diagonal center line from corner to corner. This will help us locate the center of this face. And draw a circle at the midpoint. And then just go ahead and dimension this at 1/2 inch. And in this case, when you extrude this cut, you could cut it through both, so just select through all. Okay, now the next thing we're going to do is we're going to add a flange here. I'm going to select this edge, and we're going to use that under sheet metal, the edge flange tool again, drag it up a bit. Okay, go to edit flange profile, and you could use whatever dimensions you like on this one. I'm just having a little fun with it. And we'll draw a circle, a diagonal line again to find the center of that. Draw another diameter in there. And this will be 0.25. And hit finish. Now if we want a matching one on the other side, we can mirror it. We could select the top plane, go to the mirror tool. We could go back to features here, go to mirror, and the feature we want to mirror is this flange. Hit the green check. Now let's say we'll select that top plane again to start a sketch, and we want to lighten the bracket up a little bit. So what I'm going to draw in here, I use the straight slots. Actually, I use a center straight slot and locate one right about there. Drag this out, make sure it's horizontal. Make that little cutout. And we could draw a center line in the center here. And then mirror this across. I'll deselect, actually, I'll just go to the mirror tool in advance. Oops. I exited the sketch. Just double click on it if you exit the sketch by accident. Okay, and go to mirror entities. The entities to mirror that, and then the mirror about the center line. And now I can extrude that as a cut. Now because it's cutting from the center, it's going to be through all both. All right, so now we have our bracket completed. Let's just double check this to see how it looks flattened. Go back to sheet metal, go to flatten, and there we have our flat pattern. And again, if you wanted, you could go ahead and save it, bring it in, make a drawing from that, bring in the flat pattern, and you're done. This concludes exercise 11.